Hi, and welcome to the final episode in our series on the anatomy of a digitally transformed organization. As I always say, if you haven't watched the overview video first, it would be advantageous to do so before you go into this detail. Okay, first comment is a quick summary of that overview, is that the biggest change as we move to a digitally transformed organization is to move from a vertically integrated architecture where one system has all of the logic inside it all tightly integrated to a horizontally layered architecture where you've got clear separation of the layers and channels are separated from processes from the service providers, as you can see here. The other videos cover that in some detail. Well, this final topic we're going to talk about, in many ways the most exciting, certainly the most hyped thing about a digitally transformed organization, and that is it's data driven. So let's unpack a little bit what we mean by data driven. Well, the first thing that everyone is talking about, which is absolutely true, is that the volume of data that you have is increased dramatically, and that's why we use the term a big data store. Now, certainly like you always have done traditionally, you'll bring all of your data from your existing systems that you hold in-house or in the cloud, but they are your own systems, into this new big data store, just as you used to do in the old data warehousing days. If you had them for reporting, you bring all of that data in. But unless you're one of the rare organizations that does everything itself, you'll of course have partners that do some things for you. Maybe you've got a supply chain partner that does some of your logistics, etc. You're certainly going to want to take their data that's shown here as the external entities and bring all of their data into your big data store. Maybe you've done some business process outsourcing. Maybe you've outsourced, for example, customer onboarding as part of a full BPO deal with somebody. Well, that's still your process, and you're going to want all the data about that process. So you'll certainly take all the data from that business process outsourcer and move it into your big data store. I said, but there's more. Of course, now you're going to bring a lot of IoT data, sensor data into your systems as well. Now, of course, that's particularly prevalent in asset-based systems or in government or smart cities, smart ports, those type of things. But frankly, there's probably a place for it in most organizations. And then, of course, you're going to need a whole pile of external market data that you don't control. There's some obvious examples of that. If you're in financial services, you're bringing Bloomberg's and Reuters data and pricing data. But in electricity markets, you'll be bringing in real-time pricing data on the current price of power and wholesale prices of electricity. But generally, you're now going to bring in as much of this external data as you possibly can into this big data store. Now, the second part is that you're now actually going to do some big data science and going to use some of these new sophisticated tools to identify patterns for you. You can still do that in a human factor and go and have a look at them, but the real power of having all this data in one place now is to use the data science tools to identify patterns and learn things from them. But even that is all good, all exciting, but the real promise of having these big data stores is not now we're going to have more data and more accurate reporting and better insights, but we're going to move from just using this data after the fact for reporting and analytics purposes to now move to using this data in real time, we say in Australia, in anger, to actually modify the behavior of our systems and therefore the customer experience in real time based upon that data. So as you can see in the diagram here, we got the AI engine pointing to two things, directly to the channels and to the processes. They're probably the most common things you can immediately use them for. So you can change the user interface and gather less data from a client, for example, where you've identified that based upon historic patterns, these sort of clients typically don't cause us any issues, and so let's not overburden them without asking for additional data. Let's reduce the data based upon that learning we've got, and the AI engine will make that decision on the fly and change the UI accordingly. Similarly, you might have a fast track process through your process engine that says, for these low risk customers who fit this pattern, maybe in a bank, we've seen all the people in this postcode who've applied for these type of mortgages in the past, we have an almost zero default rate. Well, the default rate, let's cut that back. Let's bring it down and let's ask them for less and have a fast track process through our onboarding. Now, that's all great, providing the data is correct. But if you've got bad data and you are making real-time decisions to modify the behavior of your systems and ask for less data and take more risk, you had better be sure that that data is right. So I guess the final twist I'd put to this data-driven piece is, yes, everyone's focusing on the size and volume of data and the new opportunities that opens to us, but actually quality becomes absolutely critical in focusing on data quality management. So a couple other points to finish up this one. First, is a kind of a semi-joking one, and we're not going to suddenly try and change the name, but in our view, actually data-driven is probably the wrong term for this thing. And why would we call that? Well, let's have a look at this. This is what's typically called the information hierarchy. And this is a fairly common concept. You go from data to information to knowledge to understanding and to wisdom. That's easily said. Let's try and make that real for you by giving you examples of what that actually means. So in data, you might have this 23, 12, 19, 1976. That's just raw data. It's just a set of numbers. It becomes information when we have to actually attach metadata to it, and we know that this is actually a date. Okay, so this is the 27th of December, 1976. Bit more useful, but still, it's only knowledge. It only really becomes the next level when you actually understand that this date is my partner's birthday, for example. Now we've got knowledge. It's really useful to us. But that's not the useful stuff. It's only when it's understanding that if I forget my partner's birthday, I'm in big trouble. That's the next level. Again, that's great, but how many of us understand that but still don't have the wisdom to actually act upon it and do something about that information, and do not forget to buy your partner a present on their birthday? Now that's the level here. So we say data-driven. Actually, what the promise of digital transformed organizations and these big data stores and the data science is actually move us to be a wisdom-driven. Actually, I'd say, to be honest, from them, it's understanding-driven. Those are, and it's the AI engine or artificial intelligence that takes us from understanding to wisdom to act. Because you can get all of this understanding from your data science, etc., but and your data lake and the big data, if you don't actually have the wisdom to do something about it in your systems, it's still not much use to you. Finally, a little bit of talk about this big thing everyone's talking about, a data lake. A couple of points here. First of all, there's a big question about, if I get a data lake, do I still need a data warehouse? In our view, yes, there's still a place for them. They are different beasts with serving different purposes, and your warehouse will still have a place to play for your traditional compliance reporting, financial reporting, analytic reporting, unknown data, regulatory reporting, all of that type of thing. There is still a place in our view for data warehouses where you have to bring this aggregated view of information, because it is structured with this data associated in the warehouse, and do your sort of analytic reporting. A data lake is where you dump raw data in, and you try and use data science tools to make inferences and turn that data into information. In fact, ideally what you want to go is to use the heuristics engines and the data science learning tools to go straight from data to knowledge and understanding, and that's the power of the data lakes. So data lake, apart from being a new piece of technology, a couple of points we'd like to make here. First of all, we think certainly in large organizations or conglomerates, there's a couple of large conglomerates we're working with where they want to use this one foundational piece of technology to bring data from numerous divisions within the group, that you should have it partitioned. Privacy is absolutely critical here. If you're putting this out in a large conglomerate, you may not have permission to actually join data from one a member of the conglomerate to another business within the conglomerate. So you have to partition it out. We show the central ring in the middle, which is actually where you can put all your common data, which there are no privacy restrictions about. For example, in this conglomerate, they can share HR data or human resources data and their finance data across the whole group. There's nothing in a privacy sense that prevents them from doing that. So this is that common area. You also see these other ingestion pools, you might call them, where you can rub raw data in. And that's important when you're starting doing some data quality management over it before you put it into the lake. And you might want to make sure that the data has some common sense to it before you dump it into the lake, or else you'll end up with what's generally referred to as a data swamp, and we've certainly seen some early implementations end up that way if you don't do it. Now these sort of preliminary transitionary ponds can apply rules on semantic data, but it can't, for example, validate that Glenn Smith's birthday is actually this birthday. That form of data quality management, as you can see in the diagram here, has to go back to your source systems to actually fix that level of data to get this right. That's it on Data Driven. Hope you found this series of value to you. Thank you for your time and attention.